First of all, you need a good soldering iron operating at the right temperature for the kind of solder and components you use. At all times, make sure you keep the hot tip of the soldering iron clean from oxide buildup and excess solder. Next, we will transfer your breadboard circuit to a strip board, which is a circuit board with, for example, holes for components at a standard pitch of 2.54 mm, which is 0.1 inch, and copper strips in one direction along the board. We cut a piece of strip board that suits the size of our project. Try to minimize how much you handle the copper side of the board, as the fat from your fingers will make the board more difficult to solder. With 2 shallow cuts in each direction, we can then snap the board to size, using for example a vise or along the edge of a table. Use a fine file to trim the edges of the copper tracks. You don't want a microscopic sliver of copper creating a short circuit along the edge of your board by mistake. We then transfer the electronic components from our breadboard to the strip board. This may take some mental juggling, as you have to think and rethink how to use the copper tracks in some kind of way that's orderly and smart. You can bend the pins of the components slightly apart on the solder side of the board to prevent the components from falling out when you turn the board over for soldering. When you're soldering, keep the tip of the soldering iron clean at all times. Wet it with a tiny amount of solder. Apply the tip to the pin of the component and the copper strip on the board. After a very short time, apply the solder to the other side of the pin, or if it doesn't melt, to the point where the soldering iron tip is in contact with the pin and copper strip. Try to use as little solder as possible, as you might otherwise build up blobs of solder that can create short circuits that would make your circuit malfunction. When you're finished soldering, trim off the pins of the components at the top of each solder joint. Don't leave any long pins, as this may also cause short circuits. Now, let's have a look with the magnifier. The solder joint to the left looks fine, but the one to the right looks slightly under-soldered, as there is still a hole visible. When you're figuring out where to place your components to use the copper strips as interconnects in an optimal way, there will be points where you want to break a strip to isolate it between different parts of your circuit. The easiest way to do this is with a 3 or 3.2 mm drill. Just pick up the drill with your fingers and twist it, don't cut yourself, and remove the copper over the hole in the strip board. Now, with a look through the magnifier, you can see that we created a perfect break in that strip. Make sure there's no copper left interconnecting across the break.